good day, everyone. Welcome again to Quantitative Methods with Simulations and Modeling. Last meeting, we discussed about regression, specifically on linear regression. So, this time we're talking about another type of regression, which is called the multiple regression. So, what do we mean by a multiple linear regression? The multiple linear regression is used to estimate the relationship between two or more independent variables in one dependent variable. Now, if you go back to the concept of linear model, we have only one independent variable equals one independent variable. For a multi-linear regression, we have more than two or more independent variables, and of course, with one dependent. You can use multiple linear regression when you want to first wanted to know how strong the relationship is between two or more independent variables. One independent variable. Okay, for example, temperature and amount of about growth. Another one is the value of independent variable. What is setting that value? The independent variable. For example, the expected yield of a crop at a certain level of rain, temperature, and fertilizer condition. So, what are the assumptions of linear regressions? So, multiple linear regressions makes all of the same assumptions as homogeneous, that homogeneity of variance, the size of the error from a prediction is the change of spot independent variable. And of course, the independence of observation. The observations in the data sets were actually collected using valid sampling data methods. And there are no hidden values among variables. So if two independent variables are too highly correlated, so where is that 0, and only one should be used in the regression. So the normality, the data allows a normalization. At the same time, the linearity line of the test through the data points is the straight line rather than a curve or some sort of grouping factor. So in other words, in multilinear regression, it is possible that some of the independent variables are actually correlated with one another. So it is important to check these before developing the review. So, what is the format for a multiple linear regression? Borrowing the concept of linear regression, where y, the dependent variable, equals alpha, which is the intercept, plus the beta, which is the slope, and x is the explanatory variable. So this time we have the following formula: y is equals to b or beta sub 0 plus beta sub 1 times x of 1 plus and so on and so forth. Meaning the independent variables have, okay, until beta sub n and x of n plus the epsilon error. So, y is the predicted value of the dependent variable, and b sub 0 is the y-intercept. Okay. The value of y when all other parameters are set to 0. So, b beta sub 1 is the regression coefficient, beta 1 of the first independent variable, also known as the effective value of the independent variable as on the predicted value. All the that's there are do the same for the however many independent variables you are choosing. While the betas of n and x of n is the regression coefficient of the last variable, while x is the model of how much variation there is in our system. And so to find the best fit line or best fit line for each independent variable, the multiple linear regression calculates three things. First, we have the regression coefficient that actually leads to the smallest overall model error, the t statistics of the overall model, and the p-value. How likely it is that the t statistics would have occurred by chance if not hypothesis of no relationship between the independent variables as actually. So in this, it then actually calculates the t statistics and the p-value, which regression coefficient in the model. So that's what the discussions about linear regressions. Then these are access websites. Okay, so demonstration time. Okay, take note on the multiple linear regression formula that in y is equals to beta sub 0 plus beta sub 1 times x 1 plus and so on and so forth. It will depend on the number of independent variables you have plus there. Okay, so our goal here is to determine which among the variables significant relationship with our dependent variable. I know the model, the multiple linear model that we will be able to develop later on. Okay, so this time demonstration we will be using R programming to calculate or to the model, the multiple linear model to develop. And there are some variables dependent. Okay. All right. So let's start share. Okay, so let's start with the multiple linear regression. So let's start to import our data sets. We're still going to use salaries data sets. So this time we converted the ranks into values, and the others as sets and discipline. A0 is A, 1 is B. While in sex, 1 is male, 0 is female. In the rank, 3 is professor, 2 is associate professor, 1 is assistant professor. Alright, so let's try for this. Alright, so we have here salaries. Let's put it in D. Okay, so we have there. Let's try to look into the characteristics of D. Alright, so there you go. For example, in this case, we would like to use the salary as our dependent variable, while the rest of the variables will be our independent variable. Right? So again, let me reiterate that our dependent variable is salary. Okay? This will be our dependent variable, and the rest of the variables will be independent variables. Okay. Alright, so let us proceed. Let's try to plot first what is going on in our data. Okay, so we have this subject last time, so let's try which one has something that there is determined by plotting it. Okay, so let's try to design model. So this is our model 2 for a multiple regression. And this time, instead of using linear model of LM, we'll be using the GLM or general linear model for these purposes. Right? So we are going to use salary as our target variable. And all of it will use all of the variables. So we just use period instead of writing everything. Right? And then try to data coming from me. Oh, I'm sorry. It's not capital S. Let's start into summary of our model. Okay. So try to look at our summary in determining our salary. Okay, so we have here descriptive statistics, okay, the minimum and the maximum. And the first and the third quartile. Okay, so our internship constant estimates 2,072. And you notice at rank and then discipline, the years in PhDs, years in service are in significant relationships with our dependent variables. Whereas in our sex is not, there's no significant relationship with our dependent variables. Why? Because of it greater than 0.5 whereas the others they are below 5% or 0.5%. Okay, so let's try to look into now. We are able to determine five significant relationships. Rank, we have discipline, the use in PhD, service. The use in PhD and the use in service are significant relationships, while the rank and disciplines, you'll notice, or 3 stars here, the data here are almost near to 0. Okay. And so you can see that rank and disciplines are very highly significant relationships, very high significant relationships with it's flat now in our model based on this data. Okay, so let's try to copy our go back to our for this PowerPoint. I'm sorry, it's not the one. Okay. So remember that this is our problem. To know the first is to know what are variables and this our salary. Okay, so therefore we will determine that. Okay, we are able to do that by using our here. So what are those variables that are highly or has significant relationships? Say the rank and the discipline, and of course the years in PhDs and the years in service. So these are the variables, okay, that are actually related. Okay. So here, remove this. The rank and the test of discipline. Okay. Yes, let's actually file over there. I need relationships with salary. While these two the year PhD and the year service are has a significant relationship. Has a significant relationship with okay. While sex, looking into this data, there is no significant sex. There is no significant relation with salary. Okay, so all you get to do is to have an in-depth discussion why that salary has no significant relationship with sex, whereas the others has. Okay, so let's try to develop now what will be now the model based on this data here. Let's try to substitute what is the intercept, the theta sub 0. The intercept there is 52,641.7. Okay, that's the intercept. Plus okay, so rank, which is 23,711.3 times rank and plus, or rather minus 14,402.8 0.8 variables. This plus we have the year PhD plus 579 times PhD plus minus 509. plus but this one is also reduced. Take this one. There you go. So this is now no. Okay. These are things that we could say that there are significant relationships between those variables to salary, while sex has no significant relationships. Now, what does these things tell us? Okay, so let's try to discuss first about rank. So for the rank, for every okay, for the rank, for everyone's increase in our rank, the salary increases for about 23,611. Same thing for the discipline, the other which it decreases 14,402.8 for every year. With the PhD, there's an increase of 574.8. While for the service, for every increase of service salary, right? So that's it for today. Very much listening on this